Good afternoon. Thank you so much for joining us for today's webinar, where we're going to learn about security in Azure, and specifically be able to kind of compare and contrast that with what you may be currently experiencing with your on-prem environment, since that may be where many of you are. But I would suspect that if you're like most of the folks we speak to, you have kind of some and some. You have some things in the cloud, whether that's in Azure, AWS, or other places, as well as resources on-prem, whether that's servers, storage, and other types of devices. So there'll be something here for each of you. So whether you've already moved some things to Azure or just considering it or planning on it, wanting to learn more, there'll be something here for you in all of those cases. So let's go. I'll be joined today by Dave Ferg, who will be doing the presentation today. Dave is one of our senior consultants. Many of you have probably worked with him on various projects over the years, and he's literally done probably hundreds of different Microsoft engagements over the years. So let's kind of go ahead and jump in. So I'll do the introductions here. Some of the things that Dave will be covering is looking at kind of that, how does Azure infrastructure improve security versus on-prem? You'll look at some of the data center security, fault tolerance. You'll look at kind of what does this all mean in the real world, which is probably the most important piece. And we'll also kind of look at it from an aspect of, as you are planning an Azure migration, since many of you may be also using this time to kind of learn to figure what you may need to do if you go towards Azure. We'll also look at what some of those security considerations are in that case. Q&A will be at the end, and I'll talk about that in just a moment. So hopefully most of you have a pizza in front of you if you requested one and you're enjoying that. However, if your pizza has not shown up yet, just note Mike Jones's email address on the screen. Give him just a few minutes in case you're trying to find your house, find your address if you're working at the office. Also, if you're at the office, we found that sometimes people's front doors are locked to the office, and the delivery person may be on the other side of that locked door in the lobby. So check there or wherever food seems to get spirited away in your office. If you still don't find it, just shoot Mike Jones an email and he'll do his level best to try to help you with that pizza conundrum. So during the webinar today, the audio is in presentation mode, which is you can hear me and you'll hear Dave, but sadly we can't hear you. But we do that so that any background noise, music on hold, any of those types of things where participants may be doesn't come through to the whole group. However, I'll be monitoring both chat and questions tabs throughout today's webinar, and you can reach me through either one of those places. And particularly for questions, just drop those into the questions tab at any point. I'll save those up, and then at the end, I'll read those questions out to Dave, and then he can respond to those questions at that point. Putting them in writing also has the advantage if you have a particular situation or something that requires more research or a longer answer, we could also we'll have that information so we could also get back with you with those answers as well, if it's not something that can be answered in the group itself today. This presentation and the recording of it will be sent to you by email later today, so you'll have that. And then at the very end, there will be an evaluation, so you'll get that as soon as the webinar concludes. And we ask if you just take a moment to do that. Probably takes 30 seconds, no more than a minute, and let us know how we did, as well as anything else that you need. And to try to make this a little bit more fun, we'll go do drawings out of those that are completed for either an Amazon gift card or a $50 gift card to your favorite restaurant. You let us know what you prefer. So a little bit about System Source. We do have some new folks to us here, so let me quickly go through a little bit of who we are. So System Source, there's about 75 of us at System Source, and we've been around as a company since 1981, working with IT professionals in South Central Pennsylvania, all of Maryland, and down to the DC area for kind of a variety of different IT requirements. So a lot of folks first come to us when they need to acquire new technology, and that could either be on end user computing side, laptops, desktops, printers, but most of the work that we do is on the data center side, and that could be either traditional on-prem or Azure like we're talking about today, or AWS, as well as we have clients with resources in co-location centers, in our data center, in software as a service apps. So their data can live and their storage can live and their computing can live in a variety of places. What we do is we work with clients when they come to us and they kind of help them pick the place that makes the most sense based on their situation, their growth plans, background, all those types of things, and we'll help them with that. So we'll be working on things like compute and storage and servers, as well as all the security pieces for the infrastructure, whether that's on-prem with things like Cisco or Meraki or VMware and Microsoft technologies for virtualization. All of the pieces that kind of make the modern data center go, those are the types of pieces that we do, whether that's on-prem or any of the cloud or other locations for them. But people are acquiring technology to improve things. So we talked a little bit about consulting, so the types of work that Dave does, as well as our cloud services. But we also do training with about 600 to 700 to 800 classes on our schedule at any one point for all the security courses, Microsoft courses, VMware, and the list goes on to probably about 2 or 3 dozen different technologies or manufacturer certifications, depending on what you need. And those can be handled both at our location, but all of our courses are available remotely as well and have been for years. Finally, where it says present is kind of our code word for professional AV. So think all of the large monitors and projectors that you would see in conference centers and in presentation rooms and in huddle spaces, etc. We do that type of work, Teams rooms, Zoom rooms, WebEx rooms, all the microphones, all the cameras, all that type of work happens right there in our presentation group, including the digital signage. And finally, we maintain all of these things around this circle there, whether on a reactive basis, you call us when you need help. That's kind of under the service and support, or a proactive basis where we are the IT department for dozens of companies in this area under managed services. So that's a little bit about System Source today. We do have some additional upcoming webinars. So there's one that's coming up in 2 weeks that's going to be on kind of building IT that is resilient, so that when there are problems, you can recover and that you can prevent the problems in the first place from cyber attacks. So that's really kind of an important area, and what we'll really dive into is you'll see that cyber insurance premiums often require not just 2FA and other types of things may be familiar with, but kind of disaster recovery plans and recovery plans that are kind of written before the fact. Then coming up at the end of the month on the 29th, we'll be looking at large-scale Wi-Fi environments. So think houses of worship or large presentation areas or large buildings, warehouse space, industrial space, all of those kinds of areas that are large, they have a lot of obstructions, may have a great density of users. Those can provide a real challenge for Wi-Fi. So we'll look at both improving what you have as well as installing new in those areas. And then finally, what's coming up, we'll be looking at, again, an Azure topic in a month, and that will be looking at migrating servers and storage to Azure. So today we're looking at securing Azure. In a month, we'll look at that one. You may want to register for that as well. And with that, let me go ahead and hand the reins off to Dave, please.
Thank you, Chris. And again, thank you all for joining us this afternoon. Hopefully you're going to get something out of this that will help you secure your current environment or help you plan for the environment you're going to go to. One of the great advantages, just go ahead and advance the slide. One of the great advantages of going to the cloud from when you're on-prem is it's already built in the cloud. At least a good chunk of it is already built. And now what you need to do is enable features. So whereas in your on-prem environment, you may need to install software, put an appliance in, or reconfigure switches and all this other thing to bring something into your environment. With Azure, you're still bringing things in, but what you're doing is you're pulling from a pool of pre-configured devices. So a lot of the security tools that you may not have on-prem are already available to you in the cloud that you would just need to take advantage of. Caveat to that would be that some of them are depending on the license you have. Granted, the higher the license you have, the more of these things you get, but they're there to use and turn on and have a more secure environment. So one of the things I'm going to be pointing out today, some of the things we're going to be pointing out today will require some of these higher licenses, like an Azure AD or Entra ID, P2 license or whatever. But it is available to you and easy to deploy. One of the things that this first image is showing is that this Azure environment is a global environment with data centers all over the globe. There are 60 plus regions and over 300 data centers where you can put your resources. So on-prem, you're constrained by your current data center, and maybe you have some satellite offices. Some of you may have offices across the country or maybe even across the globe. If you're not in that scenario now, though, you can use Azure to start dispersing your resources or replicating your resources across the globe or across the country or within the region to gain fault tolerances. So that's one of the great advantages of going to the cloud is you can locate your data, replicate your data without having to build out a new data center to do so. The data centers are built on meeting certain regulatory requirements and security requirements. If you want to read about them, you can read about them in the Trust Center, which will talk about how Microsoft deals with privacy, compliance, how its products and services meet various regulatory compliances and things. So you can do a little research ahead of time to see, if your question is, will an Azure site meet X requirement? Well, you can go up and take a look to see if it would meet a regulatory requirement, or what you may need to do in addition to what Azure is already doing for you to meet your requirement. Right? So that's one way to get yourself started. So one of the things we're going to talk about is the advantage to moving to the Azure world is you're going to gain some additional features that you may not have already in your environment. One of these things may be physical resiliency of your world. The Azure regions that we talked about, those 60 plus regions, each region is a set of data centers. So there's more than one data center in a region, and they're all connected via a resilient network. These different data centers within a region, Microsoft calls availability zones. So your devices could be stored in one data center or spread across multiple data centers within a region. And that is somewhat dependent on the service in which you're deploying. For example, there are things called zonal services that are tied to the zone in which you deployed it. So in other words, it's going to be in data center 1 or it will be in data center 2. Virtual machines are an example of that. When you deploy a virtual machine, it will be in a zone. If you deploy a virtual machine across multiple zones, and you can do that, there will be replicas of your machine in multiple zones. You are responsible for the replication of that. They also have zone redundant services, things like Azure SQL Database, load balancers, things like that Microsoft already deploys in a across the region configuration. So if you deployed an Azure SQL Database, it will be present in all the data centers of that region. So if a data center went down, that zone redundant service would continue to function for you. This image right here is an example of when I want to create a virtual machine. One of the questions I get when creating a virtual machine are the availability options. So do I want to build it into a availability zone, or I can pull that, and this is an image, so I can't do it, or I can pull down the drop down and select, no, I don't want it. If I do want an availability zone, I can either let Azure select it for me, or I can say, I want this virtual machine in zone 1. I can also select zone 2 at the same time, and there'll be now 2 copies of my virtual machine. The thing that should cross your mind right there is now you've doubled your costs because now you have 2 virtual machines running, but I can have virtual machines across zones. Can think of web servers possibly. You want multiple web servers to front end an application, and you want them across multiple zones to protect yourself against a data center failure at Microsoft. Now, data center failure is a big failure. You already have redundancy inside the data center, which we'll talk about in a minute. But this is when an entire data center goes down. A zone redundancy would let me have my services still being presented. So I have those capabilities built in. Just in deploying a VM, all I need to do is check another box, continue to answer the questions for the deployment, and then 2 machines go out for me. I don't have to actually deploy a second one. Regions are paired. So I have a region. Well, in fact, let me just bring up the next image here. If I put a virtual machine in East US region, it is already paired with the West US region. Or if I have something in the East US 2 region, it is already paired with the Central region. So that if I deploy a service and ask it to be replicated across regions, the regional pairs are used as one of the methods it would use to replicate my data. So my data is in multiple locations across the board. So you have multiple data centers per region. Regions are paired to support geo-replication. You would use geo-replication for a failover so that if region A, the East Coast, goes down, because I don't know, maybe a hurricane comes through, your data could be in region B ready to be accessed. You still need to build the redirection tools to get clients and customers to that other region, but your data is there, your VMs would be running, your Azure services would be running, and if we deploy the complete infrastructure by adding other services, like for instance, Traffic Manager as the example, I can just fail over to region B and keep my operations running. That's available to you by just being up in Azure. You know, a little flippantly said, it only costs money. So you're paying for additional machines and additional storage in each location. But it's there and it's available for you to choose when you need it. So we have redundancy within a data center. So there's everything's built on clusters with multiple copies of your data across different racks within a data center. So a server can fail, a rack can fail, a lot of things can fail, and you're still working even within one data center. But then we have redundancies of data center, and then we have redundancies across regions. So we can build a very, very fault tolerant environment. The data centers themselves are secure. Physically secure. They have the designated access point with steel and concrete fences, video monitoring, and patrols. When someone needs access to the data center, you must have prior approval, and then you're only granted access for a specific period of time. Then you're only granted access for a specific location within the data center that is 2FA with biometric improved. So as you move from one section within the data center to another, you have to re-authenticate, and you're only allowed to be in the building for whatever time you've designated that you need to be in the building to do some work. So they are physically protecting your data, in addition to some of the other security we're going to talk about and how they're logically and digitally protecting your data. So you're moving into a very secure environment. So let's start talking about some of Azure's features and the network security around various networking components like virtual networks, subnetworks, VNet peering, etc. So let's kind of see where all these things fit. So this is just a generic diagram I built to talk about some of these features. What it's showing is when you turn on an Azure presence, the first thing you're going to need to do for most systems, let's say you want to put virtual machines up there, is build a virtual network. And a virtual network is nothing more than an address space that you're going to assign, out of which you will carve subnets for your various devices. A virtual network is also a boundary. Traffic does not leave a virtual network unless you explicitly configure something to allow it to leave the virtual network. So items in subnet 1, as you can see here on the left, can automatically talk to items in subnet 2. There's system routing going on there, and these devices can talk to each other. And in a moment, I'll talk about ways you can block that. But by default, it cannot talk to things over in a second virtual network or a third virtual network. One of the ways to enable those kinds of communications, if you need to jump from one virtual network to another, is Microsoft will let you configure VNet peering. And when you build a VNet peer between, as you can see in the diagram, the one on the left and the top one on the right, now devices in subnet 1 on the left can talk to devices in subnet 2 on the right without you having to configure any routing for that. That VNet peering is going to allow that kind of communication for you. So that will, simplifies your ability to segment your traffic and allow traffic to flow between VNets without having to build a lot of specific equipment to have that happen. But if you don't want to use VNet peering, or maybe in addition to VNet peering, you can build route tables that will direct, as a particular route, like any router would do, you build a route table, any traffic from this source can get to another destination by going to this specific IP address type of logic. So you can put route tables on a subnet, for instance, that says if I'm in subnet 2 and I want to talk to subnet 1 that's down here in this VNet in the lower corner, I would go to a firewall device or some other device that I have at the end here. So we have route tables where we can very specifically control what subnets, what devices, what virtual networks can communicate with what virtual networks. So we have that level of control. We didn't lose any of that in there. Microsoft has just kind of simplified it for us. So again, you build a route table. I'm trying to get to a certain address. I want to go to a destination. These very common things that you would see if you did any kind of routing. Network security groups is how you can filter traffic in and out of a subnet or a virtual machine or whatever. Network security groups are access lists. So think of access control list. It has some default rules in it that allows by default anything inside a virtual network to run, and everything else is denied. So I can't jump out of a virtual network, but then I can add by priority other accesses in. So this particular example, I'm allowing traffic on port 443 from anywhere to get into that subnet. And you can make that very specific, from a specific source to a specific destination. Network security groups, sometimes people say it's like your Windows firewall and things like that, but it's actually an independent resource item that I can attach to a virtual machine's network interface card, so it only applies to the virtual machine. I can apply it up to the subnet, so it applies to anything in that subnet. So in this example you see here, virtual machine 2 has the access rules of network security group 1 because it's at the subnet, I'm in the subnet. Virtual machine 1, any traffic trying to get to virtual machine 1 would have to go through network security group 1 because it's at the subnet, and can have a second, more granular, if you need be, access through network security group 2, which is attached to the network card itself of that virtual machine. So I can be very specific in what traffic I'm allowing in and what I'm allowing out. And these are stateful connections. So if I'm if I normally block a particular port on the outbound, if it's a return traffic, it will allow for me. So we have network security groups. We have firewalls, legitimate stateful firewalls that we can put out and do application filtering, route layer 3 filtering, etc. And the firewalls come in various tiers or SKUs, from the basic to the standard to the premium. We talked about this in an earlier webinar. We can get you information if you need more about that. I'm not going to talk about it today, but the stateful firewalls, full-fledged firewalls of different tiers, so you have that level of protection that you can put in your environment. Private endpoints. If you've had any experience with Azure already, you know that all resources, for instance, this blob storage as is shown in this little generic diagram, a resource gets a public IP address and is accessed through its public IP address. If you don't want that to happen, you can link a private IP, which is a network card, to that service, so that the only way you can get to that storage blob in this diagram is by going to the private address that happens to be on this subnet. So I can keep all the traffic on the Microsoft backbone and I can take away the public address of the blob and only allow the communication to happen privately. So we have private endpoints where I can keep everything internal if that's the way I need it to be accessed. The private endpoint, as I was just, this is just a diagram explaining. You have a resource which by default gets a public IP address. We can turn that off and assign an internal network card that we can put in any subnet that is linked back to that service, and I can gain access to it. There's also things called service endpoints, which are similar in its concept as well. So we have these kinds of security features built into the networking. We also have things like key vaults. So if I want to secure secrets used to access resources or cryptographic keys or certificates, I can put them in a key vault instead of having them on the device or in any connection strings that I have to build. So I can use the key vault to securely store all my credentials of whatever type, and only access resources through that key vault. We're going to talk about key vault a little bit more moving on. So you can build these hub and spoke designs up in Azure, which is recommended typically, where in the hub, you have things like a VPN gateway device that supports site-to-site VPNs up into Azure, or point-to-site VPNs for end-user connectivity. You can put your firewalls that are in general use for all services. You can put that in the hub, and maybe a bastion, and we'll talk about bastion in a minute. And then through VNet peering, all my resources can be out in spoke virtual networks. So all my connections come into the hub and feed out into the spoke virtual networks, and I can deal with security that way. The bastion host is a way of doing remote connectivity to your service. It's kind of like RDP, but it's going to be done through 443. So from the Azure portal, when I say I want to connect to a virtual machine's remote desktop, I can select bastion host. And the bastion host, which is think of it as a virtual machine because it's a virtual resource that you deploy, it will proxy the 443 into the RDP, and then I can gain access to my devices. So I do not need to have a public IP address on my virtual machines. I do not need to open RDP to them, to the public interface. If I need a public way of accessing my machines and getting to their desktops, the bastion host is available to me to secure that connection. So we have that kind of security, so we don't have to open our machines up to the internet. Of course, you can always not use a bastion host, take away the public IP address of a virtual machine, and then the only way you access it is across the site-to-site VPN from your office. So that's still available to you to do that. That's not shown here in the diagram. Identity management. Now, Microsoft is big on this. Now, if you've been onto any of our webinars on Office 365 security, you're going to see a lot of the same things here. I'm going to keep it at a fairly high level because your Office 365 subscription and your Azure subscription, for most people, are sharing the same Entra ID directory. So it's the same credentials, same logins. So how you secure your Office 365 through things like MFA and things like that, we can do those same things over for users or security principals applications trying to make accesses to my Azure resources as well, because we're sharing the same directory. So our credentials, again, just as in Office 365, they can be protected with conditional access policies that enforce MFA or location restrictions. They can be aware of a risky user or a risky login, and I'll talk about that in a minute. So in conditional access, I can say what users can access what targets over what network, under what conditions, and whether they're going to be granted or blocked access. And if granted, will we require MFA, etc. When we look at these conditions, some of the things we can do conditions on is there's a user risk. In other words, this account that is logging in has been seen on the dark web or inappropriate websites and things like that. Sign-in risk. This would be unlikely travel. you're logging in from Baltimore and Salt Lake City at the same time type of thing. So these are sign-in risks. So Microsoft is always monitoring these things. If you have a P2 license for Entra ID, they will then expose to you what they're seeing and why it's a risk. Where if you have the lower licenses, you just know that they are being categorized as a low, medium, or high risk. But you can use those risks saying things like, hey, if this is a signing risk of high, prompt again for MFA before you allow it, or force a password change, etc. So that's what conditional access will do for us. Privileged identity management. So you have users that need to manage resources in your Azure world. They don't always need to be administrative accounts. We can elevate them to administrative accounts only when needed. So for privileged identity management, which comes in the P2 licensing, says a user has a standard user account, and instead of having administrative privileges, they are administrative eligible, and then they have to request that for when they want it. So when they go to make these requests, they're going to have to answer questions like, how long do I need this? You can then force them to require justification when they're doing this, and all this is going to get logged. You can force them to have another login or an MFA when they're getting elevated up. You can have a approval required. So when they request it, either there's going to be an automated approval, which just activates logs, or a manual approval where they don't get the permissions until someone says they can get permissions. So I can protect my Azure resources by elevating administrative privileges only when necessary. So when credentials get compromised, they don't have keys to the kingdom all the time. Right? We can do access reviews. I'm not going to pop up any screens on that one, where you can have managers of different departments verify that people are still needing the requirements that they've been given. So you can send out these access reviews, and the managers would then be able to answer yes to user A, no to user B, etc. We can turn on single sign-on so that we can authenticate from one location and control all that. So we have all kinds of ways of protecting the identities themselves. This is, again, no different than what we can do in Office 365 because it's the same Entra ID that's sitting behind. All of this applies to Azure as well. Now that we've protected the entities, we can protect access to things through role-based access control. Everything in Azure has a role-based access control capability where you can control who can have access to what and what level of access. All right, so in role-based access control, we have users that we defined with various permissions: owner, contributor, reader, and it's given to some resource. Like for instance, this one here is given to a resource group. So the account test user 2 is a contributor into any resource that is in the resource group lab RG1. So now I have contributor roles there. Other resource groups I have no permissions in. Just this one is how you would use role-based access control. Role-based access control can be for privileged administrative accounts or job functions accounts. So if I'm trying to do a particular job, I can limit to what roles within that job that I am going to allow them to do. And again, or just administrative level, you're going to be contributor or reader or owner or whatever. So I can be very granular that user A has aspects of contributor, user B has all of contributor. User A only has it at one VM, user B has it at the entire resource group. So I can be very granular at what permissions I'm going to allow people in. Typically, this is not something easily done for us on-prem. We many times we are relying on the operating systems to do that. Here, I'm actually putting the filters on the resource itself, on the machine itself. Plus, then we have the Windows security up inside of that as well. We can always verify, because of role-based access, we can always verify what access people have. You can check your own access. You can check the access of others, so you can audit these things as necessary. All roles are scoped. I've already hinted at that when I said user A had permissions to a virtual machine and B had permissions to a resource group. You can grant them at the management group, at the subscription level, at the resource group level, all the way down to the individual resource level. And as we will see when we talk about key vaults, all the way to, in a key vault, all the way down to the specific secret that you want protected. You know, in a list of 10 secrets, I can give permissions to a user to just one of them with role-based access control. And again, very difficult to do on-prem with what most people have already deployed. So your role assignment is based off of who you are, what definition of role you have been given, whether it's a built-in or you can customize them. I didn't talk about that, but you can customize them. And where in the hierarchy you have been granted permissions. That's your role assignment, is all of that. So it's user, role definition, and scope that has been applied. If you want more information about that, you can find it at this location here. Key vaults. Now I'm going to move through this one fairly quick, but key vaults are where you secure your secrets, passwords, if you want to think of it that way, cryptographic keys and certificates that grant access to devices so that you don't have to have them on devices or into your connection strings. Because these are highly sensitive information, we can control access to the key vault. And we can do that by controlling from where it can be accessed. So we have network level restrictions. So we can allow it to be only through private endpoints or through only from specific VNets or from specific IP addresses. So we can control the source of what can make the request. We can also put controls on once you have access, who can do what. And there's two ways in which you can do that. You have role-based access control. That's this right here. And then you have access policies. Access policies being the older one, which is what's shown on the screen here. Access policies protect types of security items. So I can have permissions to keys, and then I would have these permissions to all the keys in the key vault. I can have these permissions to secrets, and then I would have these permissions to all the secrets in the key vault. So in this example, the Cloud Shell only has get, list, set, delete, etc. to secret permissions, but not key and certificate permissions. That's the access policies. Role-based access control lets me take this even more granular. So I can grant somebody a basic role into the key vault itself. And then for a particular secret, like this one here is called App1 Secret 1. That's a secret, one secret in a list of however many secrets I'm storing. I'm going to allow these users or groups to gain access to read just that one, but nothing else. Now, these users or groups can be users, groups. They also can be application security principles as well. So it's not just interactive logins. So I can protect these things through role-based access control. Storage security. In addition to your storage being encrypted, at rest and your data in transit is encrypted, we have other security features we can around. Now, by default, all data is encrypted. It's on server-side encryption, and Microsoft is managing the keys to this. So yes, your data is encrypted. As we'll see later, we have some other options to that to add to that as well. As with everything, there's role-based access control to your storage. So I can limit it to a specific application, specific user, specific group, whatever. I can control how this data is replicated for fault tolerance. It can be locally redundant. All your data has 3 copies. Locally redundant means I have 3 copies in the same data center. So this protects me against rack failure, server failure, rack failure. I can do geo-redundant, where I have my 3 copies in a data center and I'm replicating it someplace else. So I have it outside the region as well. Zone redundant, in the same region, but my 3 copies are spread across different data centers. So I can protect how I'm replicating my storage. I can control anonymous access. I can control what to do with deleted data or whether versioning is going to be enabled. And so, for instance, I can enable backup for blobs, point-in-time restore containers, soft delete, permanent delete. Various settings I can put on here so if the data gets deleted, I can get it back. Again, like with the other things we've already looked at, I can control from where the storage can be accessed, whether it's going to be from all networks, a particular VNet, only over a private connection, etc. And you can see that here. Again, I can have the general network or whether it's private endpoint. All right. I was actually thinking I had one more thing to pop up there, so it didn't flow well. Let's talk about virtual machine security. So virtual machines, patching is like critical to security. If your machines are not patched, you're just leaving open vulnerabilities at the OS level to be exploited by access you've already started to allow, especially, like, again, the easy example is the web server. You're allowing 443 to it. So any exploit that can use that port, all the other Azure security is going to allow it in. So this is now down at the operating system level. Microsoft will help you keep these things patched. You can always do the manual patching. So you can patch as you do today. These are Windows machines or Linux machines that you're putting up there in the cloud. And you can patch them as you patch your current servers. So you don't need Microsoft to help you with that. But you can also enable, if you wanted to, automatic OS patching by Azure. So Azure will manage the patching and will reboot the servers in Windows that you're going to designate. If you have availability sets, think clusters, you can do Azure orchestrated. So they will not shut down your entire availability set in one shot. They will work their way through the availability set so that your resources stay up. So Azure can manage patches for you if you want. Again, virtual machine protection, you have network security groups, firewalls, public-private addressing. We've already seen this diagram before. So you're protecting access to your devices, either from where they can be accessed and what ports you're going to allow, etc. In addition to the general storage encryption, you can encrypt the disks, the VM's disks yourself. You can either use the BitLocker as you normally use BitLocker now through Windows and let the Windows do the BitLockering as you want it to do now. So you could use group policies and Intunes and things like that. Not Intune, but for this, but group policies, etc. Or there's an Azure disk encryption capability where, again, from the platform, it can manage disk encryption for you. So if you want to enable disk encryption for a machine, in addition to the platform encryption, you can select what disks you want to have encrypted. The keys would be stored in a key vault for you that you would have granted permissions for the keys to be stored in there. So we have that capability as well. Backups. Microsoft Azure provides you backup tools as well. So the Microsoft Backup Center, or now they've renamed it to, for the life of me, I've gone blank on the name. This is a full backup product that you can define what I want to back up, policies that control the backup of when and where, etc., and to what I want to write the backup into. What are the vaults in which I'm writing? The vaults are storage accounts, so they can be locally replicated, geo-replicated, zonally replicated, so your backups can be protected in a lot of different directions. The two types of vaults Microsoft offers is something called a recovery services vault and a backup vault. And as you can see in the lists, the different services that can be written to the different backup or to the different vaults. So as I mentioned, policies control how the backups run. So you can always create a policy. In here, we can say when the backups are going to run, how frequently they're going to run, how the retention will look. So this example is showing a weekly backup. It's also showing a weekly retention of 12 weeks of backups. If I did daily backups, I could have daily retention, weekly retention, monthly retention, yearly retention of my backups. So I have a full history that I can keep, so I can control the frequency and how long I retain it. I also get a feature called Instant Restore. In a backup, what Microsoft does is it takes a snapshot of the machine and then copies that snapshot out to a recovery vault that is in another location, and it's secured and separated from your virtual machine and is not user accessible. It also has these instant restores where it keeps some snapshots on the same storage that the VM is running on, so that if you needed to restore a VM quickly, you're not going to wait through data copy. It's already there to be just recovered if you needed to. So it has those capabilities. The backup can actually reach down to your on-premises servers as well. And as we've talked about in other webinars, it works. It really is tuned for Azure. It's not a great tool to reach down into the on-prem world. Site recovery is available to you. Remember, you're in a world now that has 60 plus regions and 300 plus data centers. So I can now replicate my machines in addition to the fault tolerance that I can build with local replication, zonal replication, geo replication. I can also have a recovery site being replicated it's my DR site. Azure Site Recovery is not just an Azure to Azure solution, it's an on-prem to Azure solution as well. And I think personally is where it really shines is in the on-prem to Azure solution, where it makes an awful lot of sense to have your DR site move up to Azure if your on-prem fails. It's still valuable to have it Azure to Azure, but on-prem to Azure just seems to bring more to the table. So this is a tool that replicates your VMs, replicates the disks, not the VMs themselves, it replicates the VMs disks to another location. It's continuous replication, and it is an application consistent snapshot. The tool allows you to run live recovery drills by bringing the DR site up online in an isolated area where you can then log in and verify that you have everything functioning as it should be. You can run planned failovers with zero data loss because you are explicitly saying I want to fail over and it will get a final snapshot. If you have an unplanned failover, there'll just be the minimal loss of since the last replication, which is pretty frequent. So there's minimal data loss there. It allows you to build recovery plans so that when I fail over, I can run a plan that says I need server A up before server B so that your clusters can come up before your front ends come up. So your AD can come up if you're running Active Directory, can come up before your other Windows servers. So site recovery allows you to not only have an offsite DR location, but allows you to test that regularly during business hours. So, and again, its purpose is if you lose the source, I have a target environment. And as I showed on an earlier slide, you still need to build the tools of how to get people to the new location. So you may have to have some traffic manager, DNS changes, things like that have to happen. But you do have a DR location that will just automatically come up and running. With Azure Site Recovery, you will pay for the disks that you're replicating. You will not be paying for VMs in the target site until you bring it up. Because what happens on a failover is it creates the VMs based off the rules that you've built and attaches the disks. So you're not paying for VMs in the DR site. You're paying, I think it's $25 a VM to replicate plus the cost of the storage, right? And some bandwidth costs with that. That's typically minimal. You want to get a bird's eye view of your security in general. There's an Azure Advisor feature. So this is a tool that most people lack in their on-prem world. That bird's eye view of what does my world look like from a cost standpoint. Here's some recommendations they'll give you. From a reliability standpoint, here's some recommendations they will give you. From a security standpoint, here's some recommendations they'll give you. If you've been into Office 365 and looked at Secure Score, well, this is a Secure Score capability. So, I can see how I stand in all these different directions. If I'd have clicked into the security ones, as this one's showing here, they will have all the recommendations that would help you create a more secure environment. So from this, you would click on one of these. And again, this is an image, so I can't click. When you click on it, it will tell you what the risk is, how to remediate it, how to implement it. And if you're already dealing with something like this in a third-party way, you can then go in and say, ignore this. I'm dealing with this through a third-party tool, and you can get a more accurate score reading. So here's that bird's eye view that it gives you of all your Azure resources in your environment. So you can, and also recommendations on what would make it more secure. And then you need to decide whether the recommendations make sense for you. And if they don't, you can mark them as ignore, or if they do, it tells you how to implement them. There's also a tool called Defender for Cloud. Now you get that for free, a version of it for free. This is another bird's eye view of your world. It acts as a development security operations solution. It acts as a security posture management solution, as a workload protection platform solution. It has a view into multiple clouds, so it's not just your Azure environment. So Defender for Cloud can reach out and take a look at what you have in AWS, for instance, and evaluate that cloud as well, so you can see what's out there and you get a bird's eye view of your cloud environment, not just your environment, your Azure environment. So it shows you what your security posture is across the various clouds, how you look with regulatory compliances, what your inventory looks like of what's unhealthy, what's healthy, what you've chosen to not be a part of this, security alerts across what recommendations I make. If you have the licensed version, it will give you attack path analysis capabilities. You know, this attack, you were attacked. Here's a log of how it came through, so you have an idea of what to remediate as you move along. So, so this is what the tool offers. Again, it comes in 2 platforms. Now that attack remediation is part of the for fee, but you get a free version of it just turned on by default. This is where you're going to get some of your recommendations and some centralized management and view of everything that's in your environment. When you move to the for fee version, which don't quote me on this, is it $15 at a PM? I'm not sure which. I'll maybe not say anything at all. You get the governance capabilities, analysis, you get data security capabilities and other things, permissions management. So you have these other tools. So if you do not already have something on-prem now, that would give you this bird's eye view, just moving to Azure, you start picking up your tools from like Azure Advisor, Defender for Cloud. The free version, like I say, does give you something out of the gate. And there's a for fee, and you can check out the pricing details there. So that's a lot of information. And I do want to kind of say, as we're moving into the summary, this is a security webinar. We could go on for hours and hours talking about all kinds of security things. I picked out a few things that I thought were pertinent to most people: storage, virtual machines, backup, fault tolerances, things like that. If you want, we can continue our conversations with you to talk about your security needs. So if we didn't get a question answered here, we can follow up with you later. Again, I just picked some random samples. Hopefully I picked something that was of value to you. So what we talked about today was the security of the data centers and the redundancy of the data centers. I think the biggest bang most people get, especially in the small to mid business areas, is the redundancy, because a lot of small to mid-sized businesses do not have multiple locations and do not generally have the capital to build entire infrastructures in the other locations. So the redundancies just being available for you to choose is a great value just moving to the cloud. We talked about protecting your authentication through multi-factor authentication, conditional access policies. Privileged identity management is available for you. Conditional access reviews to make sure that accounts are not lingering with permissions after job roles have changed, or even they've left the organization, but the account is still there and still has access to something. So there's ways of doing that centrally, or you can distribute those reviews out to managers who would know the people more, and they can review whether user A still needs access or whether user B now needs access, etc. And the access review, based on the rules that you would configure, will automatically implement what was suggested if that's the way you want it to run. or it could just come back as a request for you to manually do. So you have ways of protecting your authentication and monitoring your authentication, protecting your privileges and limiting the scope of where they can be accessed and for how long they can be accessed. We talked about role-based access control, so we can be very granular now as to who can access what machine. And this is in addition to what Windows security will do for you once you get on the machine. We have permissions to protect the machine itself, so you can be very granular as to who can access what device in your Azure environment. Very good, very helpful for delegated responsibility, where there's an administrator for each resource group or each division or something like that. We can split up permissions that way. We talked about network security with virtual networking and subnet routing and network security groups, firewalls, private endpoints, and various routing configurations of VPN connectivity, bastion hosts, things like that. So there's ways we can actually protect the network routing itself and be very granular as to what can talk to what. I should also point out, I didn't have it as a slide. I probably should have had it as a slide. There's a feature called visualization, which will map this out for you as well. So when you set your configuration for routings and things, we can go take a look in a pictorial form of what that looks like. Storage, we talked about it being, your storage is encrypted. We can control what kind of authentication, role-based access control, location controls. In other words, can I access it from the internet or just internally? The redundancies of the storage itself, so I can have storage located geo-regional. We talked about virtual machine security, patching, the network security, backups and replications in there. And again, all of this is in addition to what Windows will do for you as well. We talked about monitoring, and I don't have it on the bullet here. I forgot about that. Azure Advisor is one that will give you recommendations and for cost and security and replication and fault tolerances. And then you have the Defender for Cloud, both a free and a paid versions. So all of these features are available. That's the great advantage of going to the cloud. They can be just enabled as you need to secure your environment. Again, some of them require certain licensing to turn on, but they are there for you. And with that, Chris, I'm going to hand the reins back to you.
Thank you very much, Dave. So there was one question, but just to make sure we respect everyone's time and right at 1 o'clock, we will reply to that questioner via email. And we appreciate your question. So again, in this deck, which you'll see, there are a number of different Azure specific courses, from administrator to security, et cetera, which we do have special discounts on, so you can take a look at those if this is something that you want to pursue, and you can see that that's available for the 17th of this month. And then for the Q&A, you will get for the evaluation, you will get that after today's session. In addition, just letting us know how we did, it will kind of give you several choices there. One would be additional information on training courses, but there's also two things I'll just draw your attention to. One is an Azure Security Whiteboard session. There's no charge for that. So that will be working with Dave and really kind of going through what you have and making specific recommendations for your environment, as opposed to more of obviously the general type of thing that we can address here in a public session. The second is an Azure migration planning workshop. And that would be, again, there's no charge for that. But if you're considering moving to Azure, this would be kind of sitting down and walking through some of the major steps for there and helping kind of in that planning process at a high level. So if you're interested in those, you can just note those in your evaluation as well. So we want to thank everybody for coming together today with us. Hope you enjoyed the pizza as well as the information. Thanks very much to Dave. And we will look forward to seeing you guys on a future webinar. Thanks again, everyone. Bye-bye.